Okay, some more problems from section 9.85, and this is number 21. And we have this alternating series. Negative 1 to the n plus 1, natural log of n over the natural log of n squared. So what we can do is we can just take a look at this and see what's going to happen with this limit. Just by checking, so we can try the nth term test for divergence first. If I take the limit of the nth term, remember we can put this 2 in front by using our law of exponents. And I got the natural log of n over the natural log of n, and that just becomes 1. So I have the limit as n approaches infinity of 1/2, which is 1/2, and that's not equal to 0, so therefore it diverges by the nth term test for divergence. The limit of a sub n as n approaches infinity is not 0, so therefore that's that. So that's 21. And here's 22. We've got this series, 1 over n minus 1 over n squared. Well, I just didn't really like the way this was written in this form, so I just put over a common denominator. In other words, least common denominator was n squared, so what I need here was an n, and I had the 1 here, so I just wrote it as n minus 1 over n squared. And I can see this now as n approaches infinity. This behaves like this negative 1 is going to kind of go away, so it really behaves like n over n squared, right? Because that negative 1 will be kind of insignificant. So it behaves the same way as this. And I can reduce this to be 1 over n. So what I'm going to do is I'm going to try the limit comparison test on this one and see what happens. And I know it behaves the same way as this. So if I take that limit of my original series over 1 over n, which is the comparison, and I invert and multiply, so I get n squared minus n all over n squared. And I take the limit as n approaches infinity. Well, again, we can use our rational function term. In other words, the highest degree term is both squared, so I look at the ratio, that's going to be 1 over 1, or 1, which is between 0 and infinity, so both series converge or both diverge. So these series behave the same. They both converge or diverge, okay, by the limit comparison test. And this is our good old harmonic series. This is 1 over n. All right, so 1 over n diverges by the p-series test. P equals 1. P's got to be greater than 1 for it to converge, and it isn't equal to 1, so it diverges by the p-series test. Since they both behave the same way, this series will also diverge, and that's by the limit comparison test. Okay? I hope that helps.